a few, two examples of these questions. They take forever in the day, as you've noticed. Here is a triple integral already set up in terms of x, y, and z. But if you try to integrate it in this format, you'd have a lot of problems. In fact, I'm not even sure it's doable. So we have to convert this integral into cylindrical coordinates. Now, one of the things they do in the book is they don't tell you who the variables are. You know how I like to write x equals and y equals? So the first thing I would do in this question is rewrite it. I'd say z equals. The next variable is x, so that's x equals, and that's x equals. And the last variable was y, and that is y equals, and y equals. Away. So far, so good. To be able to convert this to cylindrical coordinate systems, don't we need to find the limits of integration, in terms of r, in terms of theta, and in terms of z? And when you're doing cylindrical coordinates, and we do have some cool things, x's become r cos thetas, right? Y's become r sin thetas, and don't z's just stay as z's. So for the limits of integration, I have this guy to deal with first. And why did I put, yeah. So z equals 8 is the big number, and z equals this guy.
That would just be, it would be from r to 8.
Agreed? Why? Because when you do cylindrical coordinates, don't you end up using x squared plus y squared equals r squared a lot? Right. Okay, so far so good. So z's are taken care of. Now, if I go to this one, and I'm just going to take the top one, but the same information, that is not very helpful. And if you take it along with the y goes from 5 to -5 kind of thing, we got to figure out what that looks like in terms of polar. I would focus on this one. That one you kind of get for free. Wouldn't a better way to look at that? Well, maybe you tell me. What would be a better way to look at that algebraically?
X squared plus y squared equals 25.
Oh God, you're ahead of the game. Yes. And when you look at that way, don't you see a whole circle? And if y goes from -5 to 5, so if I draw a whole circle, can you see the y going from 5 to -5 is how I know it's a whole circle, right? Yeah. If they had made a little change and said 0 to 5, okay? If they had said 0 to 5, wouldn't I only be talking about the top half of the circle? Okay, so that contributed to the answer, but in this case, back to the original, it's this one. So we are looking at a full circle, and the radius is 5. Are you happy about how we got all those limits of integration there? Right? If that had been 0 to 5, wouldn't I just go 0 to pi, right? And can you imagine it was y equals the square root of that? You might end up with a circle going that way, right? And depends on the story. The combination of the x's and y's will tell you how much of a whole circle or a piece of a circle. You know, because it's cylindrical coordinates, aren't you going to get a circle? Because that's what cylindrical coordinates are, right? They're a circle and then you go vertically up z. So we know a lot more stuff, and we'll now do our thing. I'm going to do theta equals 0 to 2 pi. I'm going to do r equals 0 to 5. I'm going to do z equals r to 8. And the function is called xz. So x is r cos theta times z. Now, the only thing that's left is this little piece here, right? The dr, the dz, the dθs. Okay, and the order that we put them in. What should I be writing down here?
R dz dr d theta.
Agreed? The order is dz, dr, d theta, but remember, God, it's so easy to forget that darn thing. Remember they are. Right. So I'm going to have to rearrange these. I'm going to cut corners here because I've already written up here. That's going to be r squared cosine theta z dz. Then we'll do a dr, and then we'll do a d theta. Okay, if you do this guy, you just basically get 1/2 r squared cos theta z squared, evaluated at z equals r and z equals 8. If you plug in 8 here, you get, question?
Yeah, how come it's 1/2 r squared instead of?
It's the z that I'm integrating, so it's a half z squared. I just separated them.
Yep, sorry, thank you.
Right. Okay, now you plug it in. 8 squared is 64. Half of that is 32. So I'm going to get 32 cosine thetas. And if you plug in an r, I'm going to get plus 1/2 r squared times another squared, r to the 4 cosine theta dr d
Did
theta.
you drop? I think you dropped the r squared on the 32 cosine theta.
In this one, thank you. I did. There we go. So far, so good. Can I just dot this one? Are you comfortable what we would do next and what we do after that? Great. Oh, here's something I just noticed that it wouldn't have mattered. I'd still get the right answer. Can this separate? Could this expression be separated into thetas and r's? Yeah. And so I would actually get 0 to 2 pi of cosine theta d theta. And 0 to 5, hopefully, that guy.
Oh, why is it plus? Shouldn't it be minus
Which one?
for the r's?
Oh, the second one? Yes. Well cut. Right. That guy's 2 pi. That's a polynomial. That was quite clean. Yes.
I just noticed
first
that if
I
I'm
take
going
away second
crazy, that looks like it would be 0 because then you'd end up with the sine theta, which does not, which is 0 at 0 and 2 pi.
Well done. The answer is 0. It tells me over here. And it's because this is 0 and that's a number, but 0 times number gets you 0. Yeah. I'd be cool with that process. Right. There's only one more to try out then. So this is a version of question 12. They have a -4 to 4. They have a 0 to a square root of 16 take away x squared. And they have a 0 to 16 take away an x squared, take away a y squared. And the function that we're going to be integrating would be that guy. And the order is dz, dy, dx. And now I'm going to put in what was missing, which is these are z's. These are the limits of integration for y's. And these are the limits of integration for the x's. And we are going to find the limits of integration of the x, y's, and z's, but in terms of r and theta, as you can see here. So let's do the z's. Would you agree z equals 0? Now, what about this guy? Well, if you tell me that z is 16 take away x squared, take away y squared, doesn't that just turn into 16 take away r squared? Are you happy about that one? Right, we're getting kind of used to that. Right, now this one is y equals 0 to this fella. Now I'll focus on this fella first, which I'm not going to ask Leah the answer because she's just going to tell me anyway. I'm just going to write it down. Would you agree that that's the answer? Right. If you were looking at that, isn't that a circle radius 4? But since it starts at y equals 0 to this guy, would you now agree that is only the top half of that circle? And so we are in, essentially that is the guy we're trying to do. Now for a top half of the circle, don't you only go from 0 to pi? Now, do you see the 4 to -4 is kind of already in the wash? Would you agree? I didn't really have to worry about the r values because aren't the x's matching? Right. And I almost made a mistake there. The r values from 0 to 4. Okay. Can we pretend for a minute that that actually said x equals 0 to 4? We wouldn't be using the top half of a circle at all then. If that said x equals 0 to 4, what piece would we be using?
0 to pi over 2.
Yeah, it'd be this little piece here, wouldn't it? In which case that would turn into pi over 2. So do you see how all the numbers do matter? But in some cases, they only agree with what you already know, in which case that's fine. So in the integral that we have, which is the original one, we're going to do from theta equals 0 to theta equals pi.
So just to make sure I understand, so it's so the thetas go from 0 to pi because the x is what's giving us our because it's going from a range of x.
Yeah, the x and the y together are both agreeing, aren't they? Both saying it's the top half of a circle. The x is saying from -44, which is here, but the y being 0 is telling us this, isn't it?
Ah, okay.
And here we're going to have a z equals 0 to a z equals 16 take away r squared. And the square root guy isn't that just r? And then this gets replaced by an r dz dr d theta. And so we'll be doing the integral from 0 to pi, from 0 to 4. That's basically just r squared. So what you're going to get, r squared z from 0 to that guy. And that's going to get me r squared times this fella, take away nothing. And I can separate that as this guy. And that guy. And we are done, right? I mean, pi and some ugly fraction. Let me see what the answer is for this one. And according to, ooh, I don't like that. You know, if you get an answer like that, aren't you kind of suspicious and you think you've done it wrong? I mean, that's a kind of ugly answer, but evidently it's the right one. Yeah, same working as me, it must be. Right, we've finished cylindrical coordinates, so let me tell you some things that are going to be happening. Obviously, you know about the midterm. I want to spend some time on that. But here's something that is different. I am taking Tuesday off. I'm taking my personal day. I'm allowed one of them a quarter. And I was going to go to Vegas or go out to that pub that Terence mentioned and get into a fight and get drunk and all sorts of cool stuff like that. But instead of doing any of that, I'm going to be staying home grading your midterms. So that would mean that I'll be able to get your midterms in, hopefully by sometime late on Tuesday evening. So you won't have too long to wait to get your report. Okay, so Tuesday, day off. Time to recover from your midterm. So let's go and look now at what we have in Canvas. This thing ever works. Come on, there you go. Good idea to do some more than once, especially if it's important. Right. Your entire midterm is going to be in here. It's going to be in Canvas as a PDF. All the other ones, right, these resources here that you can see, they'll all be missing. WebAssign will be missing. If you go to WebAssign, the only thing you'll see is your ebook. So you make sure you make good notes because you're allowed to reuse anything that you have written down. Anything that you see here, well, let's start at the beginning. The only thing you'll see is the midterm exam. What will be left is you'll get the PDF and it'll say Math 146 online midterm exam, right? It'll be pretty obvious who it is. This practice one, for obvious reasons, will have disappeared. That there is your Zoom meeting. That's the one that you will click on to get into this class, right? To get into the midterm. So don't use your class one, it's not the same link. That one, math information, can stay there, but that won't be of much use to you. GeoGebra and Desmos will stay there because, you know, sometimes it's useful to visualize things, right? I'm keeping this one here because you have to upload all your working to me. And I'm giving you Microsoft Lens, but you can use any other software that you have, like Cam Scanner or whatever else. You could even stick it in your printer and scan it, but I need it up and running. And I've got here a little practice one. So you can practice upload working. That will disappear and that will be called upload your working for your midterm here, or some name similar to that. In this case here, just to show you what it does, once you've got your working and it's in a PDF, you choose a file, you pick whatever it is called, and you press that, and then you submit, and that's it. When you're doing your midterm, will you check with me before you finally leave that it's uploading and it's there? 9 times out of 10, there isn't any issues at all, maybe even more than that. But there are issues, and I will look at it. And if I can read it, which is the main issue, because sometimes it's very faint and I can't see it, that's the most likely mistake. But occasionally you think you've uploaded and it hasn't worked. In which case I'll say, no, Tessa, you want to do it again? I can't read it. Or Tessa, oh, page 2 is missing. I can't see question 4. Oh, and you go, oh, darn it, I forgot to do that one, right? In which case, unfortunately, this only takes one submission at a time. So if that did happen, you'd have to take pictures of everything again and upload it in one big go. If you only upload one page, it rubs out all the others. And then I'll say, Tessa, I can only see question 2 now. Can I get to see the rest, right? So we don't want that. I'm picking on poor Tessa today, right? But that's what it is, right? Any questions so far?
So I'm assuming that since we have a Zoom link so that way you can proctor.
Yeah,
So
I want to be able to see.
Close note.
Yeah, so I want to see you. So you put your camera on, make sure there's no cheating. You are allowed to use the software that I've provided. So that means Desmos graphing software is fine. You are not allowed to use any kind of other online feature, solve equation for me thingy or anything else. That is cheating. You're getting some other software to do it. You cannot phone a friend. So don't phone Brendan and ask him the answer to question 2, Tessa. Right? Not allowed. God, I think basically, if you think you're cheating, you probably are, so don't do it. But if you're not sure about something, just ask me. So if it's physically written down in notes, it's good. So if you wrote down how you did a particular question, like the one we just did today, you know how you turn a triple integral in x, y, z's into a polar? You could write an example of that down. Now, the question you get, if I did one, won't be that question, right? So it's not like you're copying the answer. But what you're writing down is how you did it so that you would be able to look at it and you know, do what you need to do. So that's allowed. Notes are allowed. Anything I put in Canvas for you will be allowed. That's it.
So
Oh,
open
calculus allowed.
notes only, no book.
You got to remember this is only 2 hours. If you have to look through a book, you won't finish in time. So I could say no, but you know, it's not. I would strongly suggest you don't look up a textbook. Don't you have to figure out where the heck it is? Then you have to scroll through it, and then you have to spend 10 minutes reading about it, trying to figure out what the heck it's telling you. And aren't textbooks notoriously bad at telling you how to do anything, right? If you had to do that, you won't be able to do your thing in 2 hours. So my advice is don't, because it won't help you. You'll run out of time. But it is physically written, so that's a different thing. Are we good? Right, I think I've mentioned it, but you should mention things as many times as you can. That way people don't forget them. Is that it's a 2 hour exam and we have some 2 hour time slots. In your case, 10 till 12, or you can do 11 till 1. Okay, we good with that? 10 to 12, 11 to 1.
Is it going to be just the same link for both?
Yeah, they're both 2 hours, I hope. Yeah.
Okay.
You don't actually need to come in like exactly at. I mean, if you came in at 10:30, you just finish at 12:30, right? I mean, it would just adjust your start and finish time. I'll trust you to be honest about that. That, you know, when you finally sit it down and you've opened it up, you'll say to yourself, okay, that's whatever it is, 11:43. I'll give myself 2 hours. You shouldn't need 2 hours. The way I tend to design midterms is I do the questions, just the questions, not the answers. And then I do the answers. And whatever time it takes me, I just double it. So it should take me about an hour. If it takes me longer than an hour, then I take a question or 2 off to reduce the time. And if it takes me even less than that, then that's fine. That's the questions I want to ask, and I'm happy. Multiple choice, there's 10 of them. All I want to see are the answers. Terence, question.
What do you want us to do if we lose connectivity to during the meeting? I've been having issues with that on a fairly regular basis.
If you lose connection to me, you get back in as quickly as you can. And you will say to me when you arrive, sorry, I lost my thing. There's all sorts of things, we'll tell you right now. You're adults, if you have to go to the restroom, you just go to the restroom, right? I mean, it's nice courtesy to tell me that you're off, but you don't need to share it. And, you know, TMI, you don't need to share too much information. You just need to say, I have to go for 5 minutes. It could be you have to go for a coffee, because Tessa seems like she's an addict. And so she may, halfway through the midterm, I'm off to make a coffee, right? Any other questions?
Will do we have a quiz this weekend?
Oh yeah, it's already there and maybe even visible right now. Oh, don't you give me that hunch shoulder thing, Tessa. You get a quiz every time. So hopefully, there are not that many questions in this one because the questions are so bloody long. Right? That, you know, they take you forever to do one of them. Terence, do you have another question or just forgot to put your hand down? I can't hear you. Right, we're good. Okay. So multiple choice, I do not want to. It doesn't help me to see working. So just do A is 1 is A, 2 is B, 3 is C. If you don't know the answer, it's C. If it takes you longer than about 3 or 4 minutes to do, you're doing it the wrong way. So pick C or whatever letter of the alphabet you like. Section 2, I would suggest that you do the questions in the order that you find them easiest. So just do a quick scan through and pick the ones you know how to do well, and then leave the really ugly ones to the end. It just is a good way to psychologically do exams, so you don't get, imagine question 2 is the stinker. Can you imagine you spent half an hour on it and just get more and more frustrated, and then you've got 8 more questions and half an hour to go, and everything goes to hell in a handbasket, right? So you don't want that. So do all the easy ones. That's easy for me. Just do them in separate bits of paper and then put them in order when it's time to take pictures. Easy to do. Plus, if you screw up question 2, can't you just throw it away and start on a new piece of paper and do question 2? Nice and easy for everyone. I'm good. Any more questions? Has anybody got a question just they want me to do to finish with? Could we go over and then insert question here? Anybody got a question that you'd like to ask me to do?
I don't have a question like math related,
Right.
but if anybody wants to hop on Zoom and study together this weekend, if you shoot me a message on the on Canvas, we can set something up. I'm available all weekend.
That sounds like a great idea. Put your heads together, because very often what will happen is Tim will understand something and he'll say it in the way he says it, and it'll make sense. And the way I said it sounded like a foreign language. And I'm okay with that, because I only describe how my mind works, and not everybody's mind works the same as me. And that's a really good piece of advice. A different student had a really good thing that it might work for this lot. She is one of those meticulous note takers, and she has it on, I think, an Apple Pad or something. And so she is going to be sending me her notes, and I will put them online. So if any of you have really good detailed notes that you think might help others in your class, if you shoot them to me as a PDF, I'll put them on and you can look at them. I don't know if that's the case with any of you, but I thought that was a really cool idea with her. So, or even if it's just notes on one thing, I found this very helpful because I now understand how to do triple integrals. I'll put it online. Just make sure it's a PDF.
Here's just like some YouTube resources that I want to put a plug for. So if somebody's like, like doing the practice test or some practice problems on WebAssign or whatever, and they're like, I don't remember. If you wanted to see if you can find like a very specific example or just like a specific like type of question, Patrick JMT is good.
Right, what, Sally?
But if you need like more of like conceptual lecture, Professor Leonard.
Right, so what you could do for me, Sally, is if you can shoot me the URL of, I'm assuming they're YouTube or wherever they are, then I can put that in as well, okay? So if you've got any resources that you think other people would find might be helpful for them. I can put them in the chat. Oh yeah, the reason I would ask you to send them to me is that I can keep them for future reference as well. And it's a little bit more awkward for me because I have to set up Canvas and copy it and do all sorts of stuff. So if you could send me a special one as well, that would be great, Sal. I guess there's no questions and your time is valuable. So if I let you go now, you're just going to get ready, aren't you? I hope. So we should finish with a joke. Tessa, tell us a joke.
Rosie,
Preferably, oh, where's the question? Rosie, sorry.
Can I share my screen for a question to go over?
Oh, great. Yes. Give me a second. I have to do this one. And you now have permission. Let's see it. Right. Tessa, you think of a joke.
Okay, can we go over this one, find the first partial derivatives of the function. It's one of those ones that we use the product rule for, I think.
Okay, so you have a function in two variables, r and s, and it's r, the natural log of r to the 5 plus s to the 7. Okay, I'm now going to take back control so I can show you what I would do on that situation. And here we go. Right. Now, which partial derivative? Because there's an s and an f. I think I should probably do both because they're slightly different in each case. So I'm going to do the partial derivative with respect to s first. So that's really just a number, constant. So this is like 5 log of 5 plus s squared. So what do you get? You get r times the derivative of a log is 1 over this guy times the derivative of this guy, which is 7s to the 6. And then you tidy up the top. And that would be the partial derivative with respect to s. Right? Are you okay with that? Treating r as a constant, you just get r times the derivative of this log. The derivative of this log is 1 over the thing times the derivative of the thing with respect to s. That r to the 5 is 0 because it's treated like 5 to the 5. It's just a number. On the other hand, if you wanted to find the partial derivative with respect to r, you are now looking at a product rule because there's an r here and there's an r here. So it's going to be f dashed g plus f of g dashed. And f dashed is the derivative of this guy, which is 1, and g is the natural log. That plus, leave this alone, is r. And if you differentiate the log with respect to r, you get 1 over r to the 5 plus s to the 7 times the derivative of the bottom with respect to r, which is 5r to the 4 plus nothing. And then I try and make this as pretty as I can. I get this guy, that guy, and that guy combine. And we're done. So the difference between a partial derivative with respect to r and the partial derivative with respect to s is quite major, right? There's a lot of differences. Are we good, guys?